Bismillahirrahmanirrahim. Our today's topic is characteristics of scalar product. We have discussed the scalar products. Scalar product means when two vectors multiply and the result is a scalar quantity, then the product is called a scalar product. The first property of a scalar product which we will discuss is a commutative property. Scalar product obeys commutative law, that is A dot B is equal to B dot A, or A dot B is equal to AB cos theta, B dot A is equal to BA cos theta. So AB cos theta is equal to BA cos theta. If the theta is 0 degree, then we know that cos 0 is equal to 1. So A dot B into cos of 0 is equal to 1. So this is AB, and this cos 0 is also equal to 1. So this is BA. AB is equal to BA. Here, when two vectors to be multiplied are A and B, then the projection of A on B will be this one, A cos theta, and its y component is AY. When we multiply two vectors in this manner, A dot B, then we will write it as A dot B is equal to AB cos theta. If we multiply these two vectors like B dot A, then we will see the projection of B on A, that is BA cos theta, and it makes no difference if we multiply A with B or B with A, that is 2 into 3 is equal to 3 into 2, that is 2 3s are 6 and 3 2s are 6. Both will be same because it is only magnitude. There is no direction required here in the scalar product. And the second property is parallel, that is if theta is equal to 0 degree, that is we will put the theta is equal to 0 degree here, our answer will be AB, because cos 0 is equal to 1, so AB into 1 is AB. Now if we talk about the unit vectors I, unit vector j, and unit vector k, the unit vector I is along x-axis, the unit vector j we represent the direction of the direction along y-axis by j, and we represent the direction of z-axis by the unit vector k. Here, when two unit vectors, same unit vectors multiply, that is I multiply with the I, that is both are on the same axis, means the angle between them is 0 degree, that is parallel, then cos 0 is equal to 1, and the value of unit vector is also 1. So we put here the value of I, that is 1, because it is unit vector, it is unit vector 1, and cos 0 is also equal to 1. So I dot I will give you 1. Similarly, the angle between j dot j will also be 1. So it is, sorry, the angle between them will be 0. So it will give you 1 as well. And the angle between k dot k is also 0, because they are also on the same axis. So cos 0 is equal to 1, and the unit vector k is 1. So all of the values will be 1, like in I dot I, similar will be in j dot j, similar will be in the k dot k. So when the same vectors multiply, and when the same unit vectors multiply in the scalar product or dot product, the result will be maximum, that is 1. And in 2-dimensional and 3-dimensional, we know that all the axes will be perpendicular to each other, that is I will be perpendicular to j, j will be perpendicular to k, k will be perpendicular to I. All of these are rectangular components, are perpendicular to each other. Then if we talk about the product of I and j, that is I dot j, then the angle between I and j will be 90 degree, because I and j are perpendicular to each other. Then I j cos of 90, and cos of 90 we know that it is 0, and I and j are unit vectors, and the value of unit vector are 1. So 1 we put the value of I1, the value of J1, and cos 90 is 0. So anything multiplied with 0 is 0. So I dot J is equal to 0. Similar will be the case with J dot K and K dot I. So when two different unit vectors in a three-dimensional system multiply, then the result will be in product, in dot product, or in scalar product. We can say that the result will be 0. Now let us look at the example. If we have two vectors, vector A and vector B, to be multiplied, we write all of the components in three-dimensional of vector A and vector B. So the component of vector A along x-axis is AX, that is along the unit vector I. The component of A along y-axis is AY, and the component of A along the z-axis is AZ with the unit vector K. And similar is the case with all of the components of vector B, Bx, By, and Bz. Now if if you multiply the two vectors, vector A and B, then vector A is Ax with the unit vector I, Ay with unit vector J, plus Az with unit vector K, and the vector B, the x component of vector B, the y component of vector B, and the z component of vector B. Then we will multiply it in this manner. As we know, when any two quantity multiply, then the first quantity we multiply with all of the second quantity, then the second component of the first bracket multiply with all, and then the third component of the first bracket multiply with the all components of the second bracket. That is, Ax we multiply with Bx. So Ax unit vector I, Bx unit vector I. Then Ax with By, Ax, By. Then Ax with Bz, Ax with Bz. Similarly, Ay multiply with all the components, and then Az multiply with all the components. But as we discussed in previous slide, that when I multiply with the same I in dot product, it is a dot product. In dot product, the result will be the maximum value, because of the angle between the same axis is 0 degree and cos 0 is 1. So here AXI and BXI both are on the I axis, that is on the x-axis. The angle is 0 degree, so AX dot BX into unit vector I. Similarly, AY and BY, they are on the same axis, that is, this is BY and this is AY, both are on the same axis. Then the angle between them will be 0 degree and cos 0 is 1. So AY dot BY with unit vector J, and similar will be the case with the third Z and AZ and BZ. When multiply, the result will be the maximum value, because of cos 0 is equal to 1. But all of the remaining will get 0 because of the 90 degree, because here when AX multiply with BY, then the angle between I dot J is 90 degree and cos 90 is 0, so this whole term will be 0. Similarly, this will be 0 due to 90 degree, this will be 0 due to 90 degree, this will also get 0 due to 90 degree, and these two will also get 0, because they are making an angle 90 degree and cos 90 is equal to 0. So when we multiply the two vectors, when the two vectors multiplication is a scalar product or dot product, then the result, the formula we will use is this one. We will multiply the x components, the y components, and the z components individually, and will add then these three components. The result will be a dot b, whereas in a cross b it is somewhat different, which we will discuss in the characteristics of a vector product.